All right. So this is a problem that Irajan just mentioned. So it's from the Kosovo team selection test in 2020. Let me type that out here just so that the viewers know. All right. So we have the cyclic quadrilateral ABCD. Did someone new come on? Prague 123. All right. Where are you from? What country? If you're okay. Cool. Good to meet you. Thanks for joining us. All right. So we have a cyclic quadrilateral ABCD, and it has center O. Okay. So I'm going to draw in the center here. All right. And BD bisects AC. So let's think about what that means. It would probably be better, let's see, if BD bisects AC, then really what I want to do is I want to draw the midpoint here. Let's call it E. Okay. Suppose the angle bisector of angle ABC intersects the angle bisector of ABC at a point X. All right. I'm just going to draw on the sides of the cyclic quadrilateral. So obviously each of these angle bisectors will meet at the midpoint of the opposite arc of the circumcircle. Let me see if I can make this a little nicer. That looks okay. They intersect at a point X. You know what? I'm just going to draw. Let me do this. All right. We want to prove that the line passing through the circumcenters of XAC and XBD bisects OX. Okay. This is a little bit of a tricky picture. I'm going to try to make it a little nicer again. So we have XAC and XBD. I'm going to draw the centers of those two. Now let's make things look a little better. I'm going to draw OX also. Maybe I don't need to draw on all these lines. Maybe there's like another way of thinking about it that makes it easier, but for now I will. Okay, so let's see. Sorry it overlaps the problem, but I think this diagram looks reasonably nice. Let's see. So we want to show GH bisects OX. So GH is the line joining the centers of two circles, so it's perpendicular to the radical axis. Not sure if that's useful. Is this just some spiral Simon-Cowell result? Maybe. Do you see a way to apply that? Or it might just be an idea that you have. If the circumcircles of XAC, wow, you're fast. Circumcircles of XAC and XBD meet at a point. Okay. I'm going to call it P because that's what you called it. Then angle OPX is 90 degrees. We need to show OPX is 90 degrees. Let me think about that. If angle OPX is 90, then, I mean, so that would mean OX would be a diameter of the circle, OPX, and that would mean the midpoint of that would be its center. So basically, we're saying the line joining the centers of two circles passes through the center of a third circle. Yeah, so, okay, I'll check angle OPX. It is right. It is a right angle. Yeah. So what I3435 is saying, so we know GH bisects XP. So I'm gonna actually move the figure around a little because it looks like G doesn't necessarily lie on either that line or the circle, but we know GH bisects XP because G and H are the centers of those two circles. So the line joining them bisects the radical axis, which is XP. And so if GX passes through the midpoint of XP, and we want to show that GH also passes through the midpoint of OX, that's the same as saying that those two midpoints would be parallel to OP. Which is the same as saying that angle OPX is 90 degrees. Yeah. All right. So that's the same as, Does the radical axis theorem help? So we know XP passes through E by the radical axis theorem, right? Is there some easy way to see that is OP perpendicular to AB? I don't think that would be true. No. But OPX is 90 degrees. Or we want to show that would solve it. So we also know OH is perpendicular to BD, right? So basically, I wonder if there's a way to leverage that. So basically, if we let OH meet BD at a point, then we want to show OPIE is cyclic, right? Is that just some obvious angle chase? Let's see. Hmm. Maybe. I'm actually thinking about using Ricard's. Are O, E, and G collinear? That looks true. Is that obvious? O, E, and G should be collinear. Yes, that is true because O and G are the two centers, so they pass through the midpoint of HE. I feel like we have so much information here. It feels like the problem has to fall apart. Just have to find the right idea. Okay. Let me just try out something. Are OP and A collinear? No, that's not. That doesn't look true. Sorry about that. Okay, we want to show OPX is 90 degrees. So if OP meets circle at another point, that means that point would make a diameter with X. I'm just going to check the chat for 1 sec to see if who else has joined. I see Prague 2006 is joining again. Let's see. I wonder if there's a way to see all the participants without. Oh yeah. Okay. So you four guys are the participants. All right. Whoops. Okay. Back to the problem. Is OPX? How do we show it's 90 degrees? My idea was to show OPIE as cyclic. I'm thinking, what's the best way to show OPIE as cyclic? There's so many lines here, it's tricky, but. I feel like we have to use some more facts about the problem, I feel like. What would happen if OPIE was cyclic? So angle BEP, that's an angle between two chords of a circle. We'd want to show that's equal to angle POI. I wonder if IO is the angle bisector of POE. That looks kind of true. Oh, I'm sorry, I3435. I didn't even see your comments from earlier. Draw the B median of triangle ABC. All right. Is BX an angle bisector? I was trying to draw the B median, but I accidentally realized, oh yeah, BX is defined. Is BX defined to be the angle bisector? I think it is, yeah. Look at me. So basically we just want to reflect BD over BX. Okay. So that's the B median. Maybe OP is collinear with that point. No, I don't think so. No. But it might lie on this. These three might concur, right? No. Perhaps OI and the B median meet. Oh, that was the thing that kind of looked true, but no. But it does look like, let me see if OI actually bisects angle POE. I'm not sure if that's true. No, OI is not necessarily the bisector of POE. Let me just double check that. I don't think it is though. No. Is triangle IPO similar to triangle BEP? I wonder if that's true. I'm kind of just guessing here. No. This is tricky. I'm just going to try something here. All All right, show us your idea, I3435. All right, so I'm going to let M be the intersection of BX with the circumcircle. Just that. Oops. That's M. And L is the intersection of DX with the circle. Okay. I'm going to move things a little bit so we can see point L. And redefine P as the intersection of XBD and XLM. Huh, okay. Let me make the diagram, change the diagram around a little bit so that, okay. XBD and XLM. Okay, so you're saying XMLP is cyclic. All right, let me think through this. So we have the Miquel point of a quadrilateral in this case, right? So BDLM. So basically the circumcircles of BDM. So the circumcircle of BDM, XML, and then I'm trying to think, ADC. So yeah, I'm just trying to think. So the circumcircles of BAC, BDX, and XML are concurrent, is basically what you're saying by Miquel's theorem. All right. Just kind of thinking in my mind how this works. So yeah, I know the Miquel point of a triangle, but Miquel point of the quadrilateral, I'm just trying to get a refresher in my mind on it. All right, so I'm going to start typing this up. Hold on just a second. All right. Some result in EGMO and Yufei Zhao's handout, OPX is 90 degrees. There's so much stuff going on in this configuration that it just boggles my mind. But Okay, so if you have BDLM, Michaelis theorem says the circumcircles of BDX, XML. Hold on a sec. Are these points collinear? I think there might be like a collinearity. So, okay, so yeah, L, M, and E are collinear. I think that's what I was missing. Yeah, these points are all collinear basically. So Prague 2006. I'm sorry, what are you saying? Let's see. So yeah, the circumcircles BDX, XML, and then I think BEM and LED are collinear by Michaelis theorem. Is that right? So, which is why you're saying LPED is cyclic. I think I see what you're saying. Okay, I'm gonna start. Hold on just one sec. Yes, okay. All right, so I'm gonna clear out some of the stuff we did, and then I'm just gonna write the solution to the problem from the beginning. So L, M, and E are collinear. And they also have to pass through G, of course. Okay. Are you sure? Are you sure LPED isn't? Oh, you don't need that LPED is cyclic, is what you're saying? Since L, M, and E are collinear. P is the Michaelis point. Okay, so you don't think you actually use that LPED as cyclic. So is this just some like property of the Michaelis point that angle OPX is 90 degrees? Yeah. I'm going to see if I can try to prove this property. All right. Let's see. So if LPED was cyclic, can we sort of use that to help us prove it? All right. I wonder if we can prove it using power of a point. So we want to show XE times X. So we have XE times XP is XD times XL. And we want to show if we label the midpoint P is the center of the spiral similarity between BD and ML. And also BM and DL, of course. Okay, I'm just going to take that fact that you mentioned as given for now, that angle OPX is 90 degrees. All right. Hold on. All right. Draw M1 as the midpoint of BM. M2 is the midpoint of DL. And by spiral sim M1, M2, XP is cyclic. Is it that? Okay, so basically you're saying that P lies on the circumcircle of M1, M2, XP. I'm just thinking through this. Okay, so I'm going to draw the other midpoint that you mentioned. Just thinking how the spiral similarity would go. Yeah, so we want to show, we know O is on the circumcircle of X. I'll write it as M1 and M2. So we know O is on the circle X, M1, O, M2. That's easy to see. We want to show that P is on that same circle. And is it just, since P sends BM to DL, it sends BM1 to DM2. Okay, so those, I see what you're saying. And I think that, yes, okay. So I will write out this whole thing. Let me see if I can do this from the beginning. So I'm gonna delete a couple of things we added, and I'm gonna start from scratch here. Okay. I think this was the initial problem, right? Yeah. Okay. So I'm going to start from the beginning here. So we have GH is perpendicular to PX. line connecting the centers. The radical axis. All right. So then if we, and then GH also bisects PX. All right. So if we can show angle OPX is 90 degrees, that would help solve the problem. And then I3435 said to draw the circumcircle. Actually, I don't think we had this collinearity originally, or this one actually. So X, E, and P are collinear by the radical axis theorem. I don't even know if we need that, but I'm just going to write it out. Okay. So I'm going to draw that in. And then I'm going to draw in this point and this point. Okay. So I is the midpoint of arc ABC. F is the midpoint of arc ABC. All right. And E is the midpoint of AC. So that means that F, G, E, O, and I are collinear. All right. It's pretty nice. It's not often you get 5 points all collinear like that. And then we can label the midpoints of BF and DI. So I'm going to call them M1 and M2. Actually, I think J and K is good for now. So so we have angle OJF is 90 and angle OKD is 90. So that means OJXK is cyclic. All right. And we want to show P lies on that circle. And But that's true because triangle BPF is similar to triangle BPI. I think that's what I3435 was saying. Let me check that. Let me look in chat. Okay, so by spiral similarities, BPF is similar to PDI. Let me just check that for a sec, but I'm pretty sure that's the case. Yes. Yeah, that should just be an angle chase. Okay, so I'm going to write that out. And then J corresponds to K. Triangle PDJ is similar to PDK. Okay. So basically then we get the cyclicity that we want, because that means angle PJB is equal to angle PKI. So I'm sorry, PKX. And so therefore XJPK is cyclic. And then I might as well just add O to that. So XJPKO is cyclic. And once we know that, that means angle OPK is equal to angle OJX, which is 90. Okay. And then once we know that, since GH is the perpendicular bisector PX, GH is parallel to OP. So we have GH is parallel to OP because both are perpendicular to XP. And so that means that, so I'll just write it like this. So GH is parallel to OP and GH bisects XP. So that means that GH bisects OX. All right. Thanks for your patience. I'm learning myself here, but this is, I feel like, a really good problem. So yeah, thanks for proposing it, Irajan. All right. Let's move on to the next one. Let me go to this one. This one's from Belarus. Doesn't look super hard. So we have a triangle ABC. O is the circumcenter. call it O. And then H is the orthocenter. Is it 2? Is it 3? 4? Looks like 4. Okay. So H is the orthocenter, O is the circumcenter. T is the, how'd this turn to D? Oh, I think yeah, let me delete this one. How do I delete that? There we go. Okay, T is the midpoint of AO. All right. The perpendicular bisector of AO intersects BC at S. We want to show the circumcircle of AST bisects OH. So the midpoint of OH, that's the 9-point center. So I think whoever created this problem might have had the 9-point center in mind. So call that N for the 9-point center. Whoops. Okay, so we want to show that ATNS is cyclic, it looks like, where N is the 9-point center. Let me check that out. That may be, all right, so I'm going to draw the altitude from A. I wonder if, all right, so is it clear that N lies on the circle through A, T, D, and S? So we know that the reflection of H over BC lies on the circumcircle. So then DN would be parallel with that point. Dilate SN around A by a factor of 2. Okay, so basically we could form a parallelogram. So I'm going to reflect those 2 points. Maybe that'll make it obvious. Because the circle with diameter SA, the circle with center S and radius SA, is a circle through A, O, the reflection of O across BC. Let me draw this. So, okay, so S lies on the perpendicular bisector of AO, and so SA is equal to SO. And then it also passes through the reflection of O across BC, is what you're saying. So, oh, whoops, got to reflect about a line instead of a point. Okay. And N goes to the reflection of O across BC. And that's because the distance AH is twice the distance from O to BC, basically. So that's a well-known fact. And then once we know that, under the dilation, S goes to the antipode of A. Okay, so basically, since O prime, and S prime, since A, O prime, and S prime are cyclic, then if you shrink everything by a ratio of 2, the resulting would still have to be cyclic, is what you're saying. And that would solve the problem. All right, so I am going to write this out. All right. So let's start from the beginning. All right. This is for the people watching it on YouTube. Okay, so draw the circle with center S and radius SA. Then O lies on the circle. Actually, I'm going to call it omega. And then the reflection of O across BC also lies on omega. All right. So I'm going to draw that in. So I call this O prime. Okay. And then we could draw the point A prime, which is the diameter. Okay. And then the distance from A to H is twice the distance from N to BC. So that's a well-known fact. I'm not sure if this is the way you thought about it, but it's kind of the way I'm thinking about it now. So I'm going to write, so AH is equal to twice the distance from N to BC. All right. Oops. All right. And so the reflection of N over BC, so the reflection of N over BC, so I'm gonna draw that in. Where's my reflection? Oh, I'm sorry. We want to show that A, N, and O prime are collinear. So OO prime is equal to AH because of this, right? So and that means AHOO prime is a parallelogram. So that means that AN and O are collinear. Or I'm sorry, AN and O prime are collinear. All right. Okay, and now if we dilate omega by a factor of a half, then S, N, T, and D are cyclic. So I'm just going to write that out. It's clear that the reflection of A over BC lies on omega. I'll just write that really quickly. So dilating omega about A by a factor of a half. Then ATD and S, ATDS is cyclic. All right. Now we can move on to the next problem. Just kind of draw in that circle for fun. Oh, I should say N, ATDS, N is cyclic. It's important. All right. Here's the next one. I'm going to go to the one after this. Let's see. So you have an acute, this one's from Croatia. So you have a triangle ABC, where AC is less than BC. I'm going to draw it like this. M and N are the feet of the altitudes from A and B. Oops. So obviously they lie in the circle with diameter AB. Okay. The circumcircle of ABC has center O. This kind of looks like a spiral similarity in a way. And the circumcircle of M and C obviously passes through the orthocenter. No. Yeah, the other center is obviously the midpoint of CB. What do they call it? They call it S. They call this D, so I'm going to have to call BH. Yeah. That should be renamed as H. And then P is the midpoint of AB. We want to show that P, O, S, and D is cyclic. This feels kind of similar, doesn't it? It's like another problem where we're showing like 4 points like this are cyclic. Let's see. Is there another dilation trick we can use? Maybe. Yeah, what if we dilate all points by a factor of 2 again? I feel like that might get us there. Let's try dilating everything by 2. This would be pretty funny. That would mean EH. Yeah, I don't see an easy way to dilate D, but maybe there's a trickier way to dilate D. So P would go to the point that makes a parallelogram, right? So P is basically the point. I don't know if you guys have seen this on my channel, but if you take the circumcircle of AHB, P goes to that point. So P goes to F. I don't see right away where G would go to, but or I don't see right away where D would go to, but so H, E, F. So H, E, and F. Yeah, maybe it's not that great of an idea. Draw POSD. Maybe it passes through G. Could be. Hold on just a sec. No. Let me just tinker with my idea. I wonder if EF is, I think EF is perpendicular to AB. EH, P, and E are collinear. Oh yeah, I've done that one on my channel before where I showed DH, P, and E are collinear. That's a good point. And by dilation, SO is perpendicular to PD. Because SO is perpendicular to CB because the line joining two centers is perpendicular to the radical axis. So yeah, SO has to be parallel to PD. So basically that would mean that that means it has to be an isosceles trapezoid. Is that obvious? Yes. Okay, yeah. You beat me to it. I said it and then I looked at the chat and you said it. All right. So that looks fairly simple. Okay. So I'm going to write it out. Yeah, this is an easy one. All right. So let me delete a couple things. We don't need all this. Okay. So we're just using the well-known fact that CH is 2OP. So I use that in both this problem and the last. So first I'm going to write out, we have SO, it's perpendicular to CD. The two centers. Okay, and then we also have C, DH, and P are collinear, which I've done on my channel before. I could do a quick proof of it right now. So if we draw the antipode of C, then we could show HAEB is a parallelogram, and also so HP and E are collinear, and then angle CDE is 90, and so DH and E are collinear. I'll just write it out really quick, just because I don't feel it's that long. So I know sometimes people just write D-H-E. I just like to type it out for the viewers that don't already know that notation. And then HAEB is a parallelogram. That's not hard to show. So because angle CAE is 90 and so this should be, yeah, AE is parallel to HB and BE is parallel to AH. All right, so I did a super quick proof of this fact. All right, thanks I3435. Have a good rest of your day. Whoops. The text went away. Oh well, I'll have to retype it again. Right. So HP, so that means DHP and E are all collinear. Okay. And then once we know that, so since CB is perpendicular to DE, that means that means that DP is perpendicular to SO. DP is parallel to SO. And then we also have SD is half of TH, which is OP. That's by the well-known fact that I mentioned. So that's the distance from O to BC, which is OP. And so DSOP is an isosceles trapezoid.